Hi everyone, I'm Tim Wolf from the Wolf Circle. In this video, I'll explain the concept of projectile motion and go through some practice problems. Projectile motion is one of the most common applications of kinematics. Using the same equations as before, we can predict the position, velocity, or acceleration of a projectile at any point in flight. First, it is important to introduce the concept of horizontal and vertical components of motion. When solving a projectile motion question, the problem is divided into these two components as they act mostly independent of each other. At every point, there is a varying vertical and horizontal component of velocity. Let's do an example. A rock is hurled from the side of a 100-meter cliff directly horizontally with an initial velocity of 10 meters per second. What is the rock's horizontal velocity when it reaches the ground, and what is its vertical velocity? The horizontal velocity will just be the same as how it started, assuming no air resistance, because there's no force acting on the projectile horizontally, so it'll remain at 10 meters per second. On the other hand, the vertical velocity is subject to the acceleration of gravity, so it will continually increase. And so to determine the final vertical velocity, we have to use one of the kinematic equations. And since we are given initial velocity and acceleration and displacement, and we're solving for final velocity, then we can use this equation. And if we sub in the values, we will get 0 squared plus 2 times 9.8 times 100, which will eventually give us a velocity of 44.3 meters per second. To build on the previous example, let's find the actual velocity of the rock as it hits the ground. Since we already solved for the two components of velocity, all we have to do is use Pythagoras to solve for the actual angular velocity. So this will give us a velocity of 45.4 meters per second. Finally, it is also important in projectile motion to be able to calculate the initial velocities. So here's an example. A cannonball is launched at a 45-degree angle with an initial velocity of 20 meters per second. What is the cannonball's initial vertical velocity and horizontal velocity? Since the cannon is launched at a 45-degree angle, then we can either use sine or cosine to determine the initial vertical or horizontal components of the velocity, as we also have the initial velocity. So this will give us 13 meters per second for either component of velocity. Let's finish with the challenge question. What is the horizontal displacement of the cannonball from the previous question once it lands? To begin, we must find the time it takes for the ball to come to the peak and back to the ground. Thus, we must first find how long it takes for the ball to reach the peak. To do this, we can use this equation, and plugging in the values for 0 equals 13 plus 9.8 t. Then we find that the time equals 1.35 seconds. So if we multiply this time by 2 equals 2.7 seconds, then we are given the time that the ball takes to come to the peak and back to the ground, because the acceleration is uniform. This is an important fact. with uniform acceleration in the direction opposing the initial movement, the path of the projectiles will be symmetrical in respect to every variable, such as velocity and time taken. But now that we solve for time, and we are given the horizontal velocity, then we can use the displacement formula equals v times t to solve for the horizontal displacement is 35 meters. So this is the answer. Thank you so much for watching, and I'll see you next time.